After discussing the theoretical part and the mathematical expression on colligative properties, today we are going to discuss the numericals on colligative properties. First, we are going to start with the basic problems and the problems from NCERT and the exercise questions from there. Then we will be discussing some of the problems from the other book. After solving the easy and the standard numericals from NCERT, we will be going into the harder problems from different books. So let us see. Let us remember the formulas once again from the previous videos and the books, and let us start solving the problems one by one. We will start off today's problem with a question from NCERT itself. And so the question I am reading out once again, although it is there in the video itself and in the book itself also it is there, you can read it out. The question is, an aqueous solution of 2% non-volatile solute, this is important, 2% non-volatile solute exerts a pressure of 1.004 bar at the normal boiling point of the solvent. What is the molar mass of the solution? Since it is given that it is a 2% non-volatile solute, so we can consider that mass of solute is 2 gram. And 2% means mass of solvent should be 100 gram. It should be mass of solution because it is 2%. So mass of solvent should be 100 minus 2 gram, which is 98 gram. So if we remember the formula for the relative lowering of vapor pressure, it is P0 minus P divided by P0 is equal to XP. So we know it already that XP should be is equal to WB into MA by MB into WA. Now let us put the values into these formulas. So after writing this formula, let us see what are the values which are already known. We know that WB, which is the given mass of the solute, which is 2. MB, that we have to calculate. MA, that is the mass of the solvent, that should be is equal to 18 gram because it is the water that we are talking about. And WA, which is the mass of the solvent, which we need to find out, which we have already calculated, is 98 gram. Now if we put all these values, now P0 means vapor pressure of pure water at boiling point, which is 1.013 bar. So we should mention it over here that vapor pressure of pure water at the boiling point is equal to 1 atm is equal to 1.013 bar, right? So that is equal to P0. Now let us put the values into the given formula. Now it should be 1.013 minus 1.004 divided by 1.013 is equal to 2 into 18 divided by M2 into MP rather into 98. So from here we have to calculate MB only. So you calculate it. Let's see how much it is. On calculation, I have calculated it separately. It should be 2 into 18 into 1.013 divided by 0.009 into 98, which is 41.35. I have calculated this one separately, and obviously the unit will be gram per mole. So the question was The original question was what is the molar mass of the solution. So here we are getting that this is the molar mass of the solution. So this is the answer of this first question. Next question is 2.16, the NCERT problem. I'm just reading out the question. The question is, heptane and octane form an ideal solution at 373 Kelvin. The vapor pressure of the two liquid components, means the pure components they are talking about, is 105.2 kilopascal and 46.8 kilopascal respectively. So what will be the vapor pressure, means the total vapor pressure of the mixture if 26.0 gram of heptane and 35 gram of octane is mixed. So here we are calculating the total vapor pressure. That means we are applying Raoult's law. So it should be PA naught into XA plus PB naught into XP. That is the main formula of the Raoult's law. Now let us see what are the things that is given. Heptane, that means it is C7H16. So if we calculate the molar mass, it should be 7 into 12 plus 16 into 1, which comes out to be 100. And on the other side, octane, that is C8H18, it will be 8 into 12 plus it will be 18 into 1. So it is 96 plus 18, which is 114. Now after getting these two data, let us find out these two values, XA and XP, which is the mole fraction. Now in case of mole fraction, we have to find out the individual mole by total mole. So for XA, that means if A we are considering heptane, in that case it will be the number of moles of heptane we have to find out. That means it should be Na divided by Na plus Nb. Now let us individually see what is the number of moles of heptane, that is Na. It should be given mass, which is 26, by molar mass, which is 100. That means 0.26. And if we calculate Nb similarly, it is the given mass in this question. If you see, the given mass is 35 divided by 114. I've calculated the value, it comes out to be 0.31. Now if we put these two values over here, for XA it will be 0.26, the number of moles of heptane, divided by the total mole, which is the 0.26 plus 0.31. If you calculate the value separately, you will be getting somewhere around 0.456. Remember, I have calculated it separately just to make the video shorter, because here if I start calculating it will take a longer time. The purpose is the way to solve. Now in case of XB, 0.31 divided by 0.26 plus 0.31. So the values that we will be getting is 0.544. So we have got XA and XB. One is 0.456, another is 0.544. Now we have to calculate the total pressure. In case of total pressure, again let us rewrite PA0 into XA plus PB0 into XP. Let us put the value. So it should be 105.2 into 0.456 plus 46.8 into 0.544. If you calculate this much only separately, you will get 47.97. If you calculate this much only separately, you will get 25.46. So you will be getting 73.43 kilopascal. So we are getting the answer like this. The next question is problem number 2.20. The problem goes like this. It's a 5% solution by mass of cane sugar in water. That means it is a cane sugar solution, has a freezing point of 271 K. You can see it is not the normal freezing point as we know. That means there has been a depression. Anyway, calculate the freezing point of 5% glucose in water if freezing point of pure water is given as 273.15. Now this question is having few aspects. Do not directly jump into the answer. First of all, a cane sugar solution is there. That means we have cane sugar as solute plus water. Now this one is pure solvent. Then in this particular case we know that delta TF is equal to I into KF to M. I. So this Van 't Hoff factor for non-electrolytes, it is 1. So it is delta TF is equal to KF into M. It becomes little bit simplified. Now M is the molality. So we should be able to write KF into given mass by molar mass into, here it will be WA, should be into 1000. So that is the total formula. Now let us see what are the things which is given. It is a 5% solution. So we can take 5 gram of cane sugar and we can take, it's dissolved in, is by mass, so it is dissolved in 100 gram of water. Alongside, KF is not given. Delta TF, it should be how much? It should be 273. It's a depression in freezing point already. So it is 273.15 minus, it should be 271, which is equal to KF, which of course we have to calculate, WB, it is the given mass of solute, which is 5 into 1000 divided by, here you can see MA. That means here we are talking about, sorry, it should be WB by MB is the given mass of, is the number of moles as we are calculating, should be MB. Here, if we are talking about cane sugar, that means we are talking about C12H22O11. That means it is, as we all know, 342 gram. So it is 342 into WA. WA means we are talking about the solvent, the amount of solvent which is already given. 5% solution. So 5 gram dissolved in 100 gram. So it is 100. Now this part we have to calculate. So this much comes out to be 2.15 is equal to KF into 5 into 1000 divided by 342 into 100. Now if we only want to calculate the value of KF from here, so value of KF should be like 2.15 into 342 into 100 divided by, it is like 1000 into 5 into 1000. Calculate this separately. If you calculate this separately, you will get 14.706 Kelvin per mole. Now, since KF we have already calculated, see the question once again. we have taken the same pure water as solvent. So the freezing point constant, molar freezing point constant, that value will be same. So for glucose solution also, Kf value will be this much. So there also, if you want to calculate the value of delta Tf, it should be Kf into m, which is nothing but Kf, the value we already know, into same formula, it is Wb by Mb into Wa into 1000. Now Kf, as we have calculated, 14.706. Wb, it is, now glucose solution is also 5%. As we know, it is also 5% solution. So it should also be 5 into 1000 divided by Mb. It is the molar mass of the solute. Now here we are talking about glucose. So for glucose, it is C6H12O6. So as we know, if you calculate this much, it will come out to be 100 only, 180 only. So it should be 180 Wa, this value. This is the 5% glucose solution. So 5 gram is dissolved in 100 gram like the previous case. It will be into 100. Now if we calculate the value of delta Tf here, you calculate it separately by yourself, you will get 4.085 Kelvin. Now this is the depression in freezing point, mind you. So what is the actual freezing point? Means this is the depression in freezing point. We have to calculate the freezing point of pure freezing point of 5% glucose in water. That means this after knowing the depression, we have to understand that for that solution what will be the freezing point. So obviously we know that delta Tf is equal to Tf0 minus Tf. So it is 273.15 minus Tf is equal to 4.085. So obviously this value Tf will be 269.07. So this is the final answer. Next question is a different type of problem, I would say. The question goes like this. It's also 2.21 from NCERT. The question goes like this. Two elements A and B form compounds having formula AB2 and AB4. Now in this case we must understand that it is A and B. Same two elements are forming the two compounds AB2 and AB4. Now when dissolved in 20 gram of benzene, the formula is already given, although not required, we know it very well. When dissolved in 20 gram of benzene, 1 gram of AB2, that means they are talking about this compound, lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. The molar depression constant for benzene is 5.1 Kelvin kg per mole. Calculate the atomic mass of A and B. Now, two compounds AB2 and AB4, they have been dissolved in benzene, which is 20 gram in both the cases. They are forming two they are forming two solutions, but since the compound is different, their solubility may be different, their vapor pressure will be different, so their freezing point will also be different, and due to which we have to find out that A and B, what will be their atomic masses. So let us see how we can solve it. We know that delta T F is equal to Kf into m. Delta Tf is equal to Kf into m. Here we are considering I is equal to 1. So now let us put the formulas. Here it is given delta TF is equal to 2.3 Kelvin, WB which is 1.0 gram, WA which is 20 gram. WA is the amount of solvent which is benzene, and this is the amount of solute which is, in case of the compound AB2, we are putting these values. And KF is also given, which is 5.1 Kelvin kg per mole. Now, if you want to solve it, the formula goes like this. Delta TF is equal to KF into WB by MB into WA into 1000. We are just substituting the value of molality. Now, if we just put the MB, it should be equal to KF into WB into 1000 divided by WA into delta TF. Let us put the values. 5.1 into 1.0 into 1000, let us put 1 only, by 20 into 2.3. I hope all the values are known. All these values are given. So the answer we are getting as 110.87, the value of MB. This much we are getting. And on the other side, for compound AB4, similarly, delta TF is given as 1.3 Kelvin, WB is given as 1.0 gram, WA is given as 20 gram. And since it is also the benzene in which it is dissolved, so KF value will be same. So KF should be same. So similarly, if we write MB, it should be equal to KF into WB into 1000 divided by WA into delta TF. Now the value should be 5.1 into 1.0 into 1000 by 20 into 1.3. If you calculate it separately, you should get 196.5. Now what we are getting, this is the molecular mass of AB4. So we have got two molecular masses. One is this one, which is for AB2, and this one is for AB4. Now after getting these two values, this is not the question, by the way. We have to find out the atomic mass of A and B. So how to get it? Here you see, if we calculate separately, this one we can write A plus 2B. Why? We are considering the atomic mass of A as small a, and we are considering atomic mass of B as small b. So for M of AB4, it should be A plus 4B. Now this is equal to its molecular mass, which is 110.87, and here it is equal to 196.15. So what we have selectively done is, we have said that for element A the atomic mass is small a, and for element B the atomic mass is small b. Now we have written down two equations, and if we write as 1 and 2, so obviously if we do 2 minus 1, it will be minus 2b is equal to minus 85.28. You can do that. You are getting B as 42.64 nearly. And obviously if you substitute the value of B in equation A, it will be like A plus 2 into 42.64 is equal to 110.87. You will be getting around A is equal to, calculate it, you will get 25.59. So what we are getting? We are getting this value of small a, which is nothing but the atomic weight of A. We are getting the value of small b, which is nothing but the atomic weight of B. So like this way we have calculated the atomic mass of A and B. First we have calculated their molecular mass from the known formulas. Then we have just allowed this trick. We have written two equations. From there simply we have calculated.